Okay, let's go ahead and get started. I just pushed today's lecture to GitHub, so you'll want to pull that. And once again, and I'm not going to do this every single time, but for now, you want to change into your own repository, whichever directory you have that, right? So currently I'm in there. And right now, if I list off the directory files, I'm up through 1.3, but I'm going to pull, assuming everything is configured. I'm going to do git pull upstream main. And there we go. It's now pulled file 2-1, and I can get started here. All right, and I'll just go ahead and push it back to my own repository. But that should be it. And once you have that, you can fire it up. Okay, so let me. Oh, I have to publish this week's module. And here we are. Okay, so we're going to take a look. This is our lecture for today. And let me go ahead for here. I'm going to just clear all of my outputs. I'm going to restart the kernel and clear all outputs. All right, so today we're going to talk about functions in Python. And I know your homework deals with a lot of functions. And so, perhaps you looked into like how to write functions in the format there, but we'll cover that today. And we'll talk about some basic ideas regarding functions and scoping and how Python looks up variables and whatnot. But I hope this is enough to at least get you moving in your homework. All right. And if you haven't started, I recommend just kind of testing a few things out. One of the things you want to make sure it works before before waiting too long is you want to try saving your notebook or exporting your notebook as say like as PDF or something, and see if everything is kind of functioning properly there. All right, so I start off and I say, all programs can be reduced to the following instructions, and this is absolutely true. Any program, even like, your most advanced computer games, okay, can be boiled down to this. You have input, you have output, you have math being done, and then you have kind of conditional execution and repetition. And so you get input from a keyboard, all right, or like a controller. So even if you think about just any kind of complicated game, you've got input, and then the output is what's going to get displayed to a screen. Right now our programs will probably just input from a keyboard and output texts to a screen. But a video game will output basically pixels to a screen. Like it's going to say this top left corner should be the color black, and this next pixel should be the color gray, and so on and so forth. And basically, if you're playing a game, it's like what you're seeing on the screen is the output, and it's basically what color every single pixel should be, right? And there's math, right? Math performs a mathematical operation, and basically everything that happens is some kind of math calculation. And so, if you're playing a simple video game, the math will be like, okay, based on the input, which was jump, we should move the pixels associated with our sprite, our character, up, and it should follow kind of this quadratic equation to kind of indicate that it goes up and then it comes back down. Okay, so that's being math, right? And if you're playing, a 3D game, the math just is a lot more complicated, but it's just math in terms of like, okay, based on this, if the light is coming from over here, then it does a bunch of math to figure out, okay, what should the color of this particular pixel be? What should the color of the next pixel over it to be? And if you do it right, it's going to look like a 3D image or something. It's going to look like, a car or Spider-Man or whatever it might be. Okay, it's just math. It's the math thing here is like it's just written like one bullet point, but like it's basically a lot of complicated math is going on there, right? And some of these require like so many operations that you have to buy like a $1,000 video card in order to compute the math quickly enough to have 60 frames per second, which is, I guess, the gold standard of smooth video game playing. But basically, that's just what's happening, right? Okay, and then conditional execution is basically like, oh, okay, if something happens, then do this appropriate code, right? If your character runs into, the enemy, then execute this code where, you take damage. Or, if we're doing something else, it's going to do something else, and then repeat, do the same thing repeatedly, usually some kind of variation. So everything can be boiled down to this, even, the most complicated of stuff. And how do we execute that? It's all run off of functions. And, I think you're all familiar with the concept of a function. And here we're going to talk about how functions operate in Python. So a function call requires that we have the name of the function. And then to indicate that we want to actually execute the function and not just refer to the object itself, we use parentheses, okay? So functions are objects in Python themselves, and if you don't use the parentheses, it doesn't actually call it. It's kind of like if you just say like the word jump, but you don't kind of call it, you're not telling the person to actually physically jump. You're saying like, okay, jump is the definition of like lifting yourself off the ground or something, right? Okay, so here we can just say, okay, what is the type is a function, okay? The argument here is the number 42, and because there's no decimal here, 42, the type is going to be an int, right? If I do 42.0 or 42 points, now it becomes a float. If I put this in quotes, this becomes a string, but I'm just going to leave it at 42 here, right? So this is an integer. All right, so again, functions themselves are objects, and so if you don't use parentheses, like for example, I call the function, not call the function, I just refer to the function print just by name without any kind of parentheses. Here it just says, oh, you're talking about the function print. You're talking about this concept, this idea, this function thing itself, but it's not actually going to execute anything. Here we're going to call the function. I'm going to say print out the word hello, and it prints out the word hello. I say print out this tuple 1, 2, and 3, and it prints it out. You can also provide additional arguments, such as, oh, I want, instead of spaces to separate the values that I'm passing it, I want it to be separated by dashes. All right, so there's optional arguments that it can do. Now, of course, we wonder like, okay, well, how am I supposed to know what are the arguments? What are the arguments that apply? Well, you can always ask for help. You can always ask for help. In Jupyter, you can hit Control-I, okay, and it will give you some contextual help regarding kind of the thing that we're looking at. So here I've got type, and so it pulls up the relative help there. And so kind of depending on which cell you're in, it'll try to figure out like what function are you asking about. So that's a very handy thing, I think. In Python, you can do Control-I to kind of pull that up, or you can call for it directly, right? So I can do help, and I say, give me help on this particular function print. And if I do that, it basically prints out the message that was here. Okay, so the contextual help says, okay, these are this is how you call the function, all right? And I can't emphasize this enough. And a very important skill is being able to read the help files, okay? Being able to read the help files and understanding what it's saying, right? So first, generally, whenever you look up a function, it's going to tell you, okay, the name of the function, and these are the arguments that get called, all right? So here it's going to print out the value. You can pass additional arguments, and it says, okay, these are the additional arguments, separator, end, and it tells you what the default values are, right? So here the default separator is the space. The default end thing is a new line, okay? And the default kind of output is what we call the standard out, which just means like put it onto your screen, okay? So even though it says file, Okay, it's not necessarily a file, but you can say, like, you know, when you print, I want it to be stored in a text document, and you can give it the name of a text document and stuff like that, okay? And flush, whether to forcibly flush the stream, and you can ask, you know, what exactly does that mean in terms of, like, you know, for a new text document, do we like wipe it out and stuff, okay? And all of the help kind of, each of these arguments tells you exactly what they're referring to. So please kind of get used to reading the help, and you should make a habit of anytime you encounter a new function, at least look up the help and give it a cursory glance anytime you encounter a new function. Okay, just a little side note on single and double quotes, all right? So when we're talking about strings, you can either use a single quote or a double quote to define it. And so here, I've got double quote, and within the double quotes, I have a single quote mark, all right, for the contraction can't. And this is fine. This doesn't produce any kind of conflict, and it just prints it out, okay? Now, if I used a single quote to kind of define the string, then this apostrophe here causes some trouble because it closes off. It ends the initial quote, and so this breaks it. I end up getting an error here. Okay, this is invalid syntax because it says, okay, and it points out at the character T, like, I don't know what you're trying to do there. I'm expecting a comma or something to separate out the arguments, and it says, you know, we can't do this. So if you wanted to kind of define a quote with single quote marks, you can, but you would have to escape anytime, any further instances of the apostrophe or the single quote mark here. So this works. Okay, and it prints out like this. Okay, you can also, like, you can put double quotes within single quotes, and similarly, if you wanted to define a string using double quotes and you wanted to insert double quotes, you'd have to escape them with a backslash. Right? And so this, yeah, this just looks weird, but it, you know, it doesn't like cause errors. It doesn't break the code, whereas something like this does. Okay, so just keep that in mind. Sometimes you run into problems, and it's just because you forgot to, you know, escape out a quote mark or a tick mark or something, and it's trying to close off the string there. All right, so let's go ahead and define a function. And so here I'm going to define a function. We're going to call this function shouting. So to create a function, you use the keyword def, okay, to define. So we're going to say define, and then you give it, the function name. So in our case, we're going to create a function called shouting, and it's going to come with arguments, and you use a single quote. And then you indent any lines that are associated with the function. So here, and then if you want the function to return something, you have to use a return statement explicitly, versus like in R, the very last line inside your function, inside that curly brace, would be returned. In Python, you have to clearly specify return. So most of your functions will start off with define, and it's going to do something here. Yeah, you have a question?
Why do you put print instead of return?
Yeah, so you can put print, and then your function will print it out. But it doesn't, print returns a none. So there is a distinction. And I want to kind of show you, like, so you'll notice here, whenever I called print, I have the input, but then I don't have an out, okay? Whereas like back here, when I didn't call print, when I called type, I had an input for and I have an output for, okay? So there is an output. Over here, prints don't produce outputs. They put stuff onto the screen, they put stuff into whatever file you told it to, but it actually doesn't create an output. So like you can't, so this is something different in R. R print returned itself invisibly, or not invisibly, it just returned it onto the screen. And so it would, you could take the result of print and like store the result of that and use that later. Okay, that's not going to work here. So, so let's just kind of look at this, and maybe I'll show you a couple of examples of how this. I think I've got all of this stuff in in these examples here. So we're defining a function. The function is called shouting. And the argument that it takes is going to be, we're just going to call it phrase, right? So you could put whatever you wanted to do, but here I'm going to take phrase. Phrase, it's going to expect a character string. And the character strings come with some methods, right? And we'll refer to these methods later, and we'll learn about all of them. But one of them is dot upper. Okay, or I don't even know if this is a method. This is technically an attribute. Okay, and so you can take this this string, and dot upper basically returns the string but in uppercase. And so I'm going to take the thing. I'm going to take whatever it is. I'm going to make it uppercase, and then I'm going to add 3 exclamation points. Okay, and so it's going to take whatever phrase we enter it, and it's going to come back, and it's going to look like we're shouting, right? And we're going to return the shout. Okay, we take this creates a new string, we're storing that as shout, and it's going to return that thing. Okay, so if I type in the text, hi, my name is Miles, right? So if you got this text, this seems, because it's all lowercase, it seems like a meek thing. But then if I enter this, suddenly the personality changes, right? And now it's like a little overbearing, right? And you can put in whatever. And again, it's expecting, whoops. Like if I did shouting, any kind of other thing, like thank you, all right? And then, it does exactly what we asked it to do, okay? Now what happens if I put in the number 5 here? Okay, if I put in the number 5, I get an error, okay? It says it took in the number 5, and as far as the phrase goes, the 5 is an integer, and then it's trying to look for the uppercase. What's the uppercase version of an integer? And it says, that doesn't exist. I don't know what you're talking about, okay? So I'm going to modify, right? And all I'm going to do is I'm going to take the phrase, and we're going to attempt to convert it to a string. And so this function, string, str, takes whatever object it is, and it's going to try to make a string version of it. And so we can just kind of see what it does, right? So if I do string on 5, it's going to say, oh, okay, here I can do that, right? And if I give it like a Boolean value, it just basically wraps it up as a string. And if I give it something that's a string anyway, it keeps it as a string. So no real problem here, okay? And I think, even stuff like lists, all right, it just wraps it up in quotes, okay? And it's able to successfully turn a lot of things into strings. If it fails to do that, then it'll let you know, okay? But anyway, that's what we'll do. And so so now I can take something, and we can return 5, right? Like, okay. All right. So all of these things, I had return, shout, right? And because I returned it, I can take the thing and I can store it, okay? So if I do shouting hi, I can store that as, this is going to be my greeting from now on. And so, and what is my greeting? My greeting is going to be this, okay? If you don't use a return, right? So here I have the same thing, okay? We're going to just take the thing, I'll call it quiet. And basically we're going to just take whatever it is, and we're going to make everything lowercase, all right? And here I just put the thing at the end, but I didn't call return. So if you don't call return, then the function is going to return what we call none. So I'm going to define this function quiet. I run quiet on this string, all caps hello, and I say whisper, and there's nothing, okay? So so this is more like silent, okay? And if I ask, okay, well, print it out, like we forcibly print it, okay? and it's going to say, yeah, there's nothing there. There's none. Okay, basically no value. No value is associated with this. All right, and what's the type? It's none type. So if you actually wanted to get it to work, you'd have to do a return. Okay, and so now this will work. Okay, so if I returned it, then we can take the output of quiet, store it as whisper, and then whisper will have a value. But if you don't use return, we're going to get that. Okay, and if I did this, all right, okay, anytime I execute it, all right, so here, notice what's happening. Because I called print inside the function, whenever I call the function, it actually prints stuff out to the screen, okay? But does whisper actually contain anything? It doesn't, okay? And if I forcibly print it out, it's a none, okay? I kind of want to pause and make sure we understand what's going on here, right? So printing, anytime, because the function has print there, anytime I call it, all right, it'll print it out, okay? But is there anything actually there? What's the type on this? It's none type. So because it gets called, it's going to print it out, and the return, the value on type here is going to be none type, okay? So if you want it to work, you have to use return. All right. In Python, you can return multiple values, and they're going to get kind of grouped together in what we call a tuple. All right. A tuple is like a list, but we say it's immutable, and I'll define all of that a little bit later. But just know that functions can return multiple values in a form called a tuple. So, for example, I'm going to create a function called powers of some number, and we're going to get the square and the cube, and it's going to return the number itself, the square, and the cube. All right, and so this will return a tuple of 3 values. And so here, when I call powers of 3, I get 3, 9, 27. I can call powers of 4, and I'm going to get 4, 16, 64, so on and so forth. All right? So it's returning multiple values in this thing called a tuple. And a tuple, you can tell a tuple is a tuple because it's parentheses and then values separated by commas. Okay? Whereas lists, which we haven't really gotten into, will use square brackets. So lists will have square brackets. Tuples will have curved brackets or curved braces or parentheses here. So one nice feature of Python is what we call tuple unpacking. All right. So if a function returns a tuple, we can unpack it into separate elements. So I could do powers of 3, and I want it unpacked into x, y, and z. Right. And so it's going to take the 3 values of powers of 3, the 3, 9, 27, and basically x is going to be 3, y is going to be 9, and z is going to be 27. Right. So I can say, okay, what is x? X is 3. What's y and z? 9 and 27. All right. You can also, you don't have to unpack it. So I could do powers of 4, and I'm going to just store it as j. So j is going to be the entire tuple itself. And now I can refer to any values within the tuple using square brackets. So I could say, okay, give me the 0th element of j. So Python uses 0 indexing. So that means the first element is going to take on index 0. The second element takes on index 1 up to index n minus 1. Okay, so I could say, okay, what is the 0th or the first element? Okay, 0 index element is the value 4. What's the index 2 value? And that's going to be 64. So you can do that. If you want to do tuple unpacking, then the number of elements that are going to be unpacked has to match the number of values being assigned. So this is not going to work because powers of 5 returns a tuple of length 3, and I only have 2 names, right? So it's going to say too many values to unpack. It sees G and H, so it's expecting only 2 values to unpack, and it wants to unpack 2 values. And here, when you run powers of 5, it's getting a tuple of 3, and it says we have a problem. Okay, so this is one really nice thing about Python is that its error messages are actually helpful. All right, so it says too many values to unpack, and you go, and it's right here at this line, and you go, oh, okay, that's great. The error messages become a little bit unhelpful after you've loaded a whole bunch of libraries. So like sometimes you're doing something in Pandas or NumPy, and you'll encounter an error, and it'll be like some line that applies to like it's like within NumPy's code. But if you're like writing your own code and stuff, and you encounter an error, a lot of times the messages are quite helpful in figuring it out. All right, is that okay regarding all this tuple unpacking? Okay, let me go ahead and give you your first view quiz answer, which is the letter C. C as in cat. C as in cat is your first view quiz answer. All right, so it's worth mentioning or talking about the flow of execution, which I think, a lot of programs kind of, interpreted languages, so R has a similar rules for flow of execution, but basically you start at the top and it just reads one line at a time, one statement at a time from top to bottom. And when you define a function, the function definition doesn't alter the flow of execution. It just kind of keeps writing. It just says, okay, we've defined this function, and the lines inside a function don't run until the function is called. So you could write a function where there's all kinds of errors or things that would stop or break your program. But if it's just part of the definition, like your code will run just fine, okay? If you never actually call that function. So if you write a function intentionally with errors in it, hoping it'll break it, okay, you can load the entire program, and as long as you don't actually call to execute that function, you're not going to encounter any errors, okay? And it's only when that function is called and you say, all right, let's try to run this thing, that's when you'll encounter it, right? So you can kind of think of functions as almost like instructions, like in a recipe book or something, right? And you could write a cookbook, and one of your recipes says like, pour gasoline and light it on fire, all right? And that would ruin your house. But you can print this book and look at it and nothing happens, and it's only until you say, all right, run recipe, execute order number 66, and then that's when things blow up and break. So it's only until that actual function gets called where like this stuff happens, okay? So like just having it defined doesn't do anything. Okay. When you are inside a function, the arguments of a function are assigned to variables that we call parameters. Right. So here is a very silly function. Okay. And it says print twice, and we're going to call this thing Bruce, and it's going to print out Bruce. Now, I don't know why you would name your argument or your parameter Bruce, but there's no rule against it, okay? And all it's going to do is it's just going to take something, whatever argument gets passed to it, and it's just going to print it twice, right? This is like a very ridiculous function that doesn't, okay. So a lot of this is, so I'm using examples from the Think Python book, and the author enjoys like Monty Python, and there's kind of a, I don't know if Monty Python is this very British sense of humor, and so anyway, one of their things is spam, and so you can do we can do print twice, and we pass it the value spam, okay, And so the argument that comes in is just this string spam. It gets assigned to the parameter name Bruce, and then it calls print whatever value Bruce has, which is spam, and it's going to print it twice. Okay. Here I'm going to import math, and we're going to do some math. I'm going to do pi over 2, right? And then we ask, what is the sign of that? All right. And it says that's going to be 1.0, and it prints it twice. Okay. Here I've got spam times 2, which is going to be spam, spam, and we're going to print that twice, and we get spam, 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 spam. Okay. All right, what's going to happen here if I do print twice, spam? What do you think this is going to do? What will we see? Yeah.
It'll first call the inside.
Okay.
Twice,
So it'll call this first.
So we'll get 2 spams.
Okay.
But then that object does not print twice, doesn't return anything, so that's none. So it'll print none twice.
Yeah. So we're going to get spam, spam, none, none. Okay. Very good. So what happened here is first, starting, when you have functions nested in each other, it starts on the innermost function. So we called print twice on spam. So it executes that and it prints spam twice. And then what does print twice return? It returns a none object, because if you look at the definition of print twice, it actually doesn't return anything, right? And so if it doesn't return anything, it returns none. And then when you call print on none, it just prints out none, okay? So that's what we have here, right? So print spam again, and then print twice returns no value, returns none. And so the outer print twice call, prints none 2 times here. Okay, so let's talk a little bit more stuff, all right? So here we have a function, and the function is called stuff. And all it's going to do is it's just going to print out the arguments that we give it, A, B, and C, and it's just going to print out A, B, and C. So this is not interesting. If I call stuff on 1, 2, 3, it's going to just say, all right, let's print out 1, 2, 3, and it just outputs that, okay? It doesn't like this, because when we define this function, it says, we've got 3 arguments. We're expecting 3 arguments, so if you only give me 2 arguments, it says, hey, you're missing 1 required argument. We're missing argument C, right? Because it sees 1 and 2 and says, okay, 1 goes to A, 2 goes to B. I need a thing for a C, and I can't do this, right? Right? It's kind of like, somebody gives you instructions, and they say, okay, here's money. I need you to go to the store and buy, and then they just leave it at that. And you're like, buy what? What am I supposed to buy? And you can't do it unless you have that particular thing, right? And so sometimes you go, okay, well, if I don't actually tell you what to buy, like this is the default thing you should buy, eggs and milk or something, right? And then you can just say, okay, I need you to go to the store today, and without any instructions, you can be like, oh, okay, they must mean go pick up eggs and milk or something. So you can define these kind of default values. But a lot of times, yeah, if you don't define a default value and you say run this thing, the computer's gonna be like, what do you want me to do, right? What am I supposed to purchase? What am I supposed to execute here? So here I'm just giving it some default values, and you just put them in the equal sign here, okay? A1, B2, C3, print that out. So you run it, junk, and it gets 1, 2, 3. Okay, uses the default values. If you only specify one of these things, I'm going to say junk 4, then it uses it positionally, and it's going to take the 4, and it's going to assign it to A, and then it's going to use the default values for B and C. So this is going to put out 4, 2, and 3. Here, I use the argument name, and I say, all right, B is going to take on the value 4. And so it'll use the default values for A and C, and I'll do 1, 4, and 3. Here I have 3 values, 5, 10, and 0, and so that will go A, B, and C. positionally. It goes positionally, and so that's no problem. Okay, Python does not like when you try to mix positional with named arguments. So here I give it a 5, and then I give it a equals 10 and b equals 0, and Python says, you gave me a 5, and because you gave me a 5, I thought that was a, and then now you're telling me a is 10, so what am I supposed to do, right? So it complains, right? It says, I got multiple values for a, and I'm not, please fix this, right? So you don't, when you give it the argument names, you don't have to put it in the correct order. You can say C is 5 and A is 10 and B is 0, and that's fine. That's no problem. But it doesn't like when you try to mix these things up, okay? I wonder, will this work? Okay, this actually works. So positionally, so if you give a first argument like this, it can figure this out. But because positionally it's going to say, okay, this goes to the first thing for A, but here I'm getting a second value for A. Okay. I think that's okay. Let me go ahead and give you your second view quiz answer. Second view quiz answer is the letter B. B as in bear. B as in bear is your second view quiz answer. All right. When you run functions, okay, the variables and the parameters and all the kind of values inside a function, they are local, which means they only exist inside the scope of the function. And they don't interact with things inside and outside. And so here we're gonna reuse our function print twice, and then I've got another function, and we're gonna call this cat twice, okay? And cat kind of concatenate. We're gonna take part 1 and part 2, and we're gonna just kind of glue them together. We're gonna use Python's string functions. We're gonna glue them together with a space in between. That'll be the result of the cat, and we're gonna print out that result twice. Okay. So here I'm gonna define line 1 as bitty bitty and line 2 as bomb bomb. So this is reference to a Selena song. And so I call cat twice line 1 and line 2. So it's going to glue those two parts together, bitty bitty bomb bomb. And then it's going to print it twice, right? So we get that, and I don't know. All right, it's a fun song. All right, one thing is that the variable, this variable cat, which gets used inside this function, is destroyed as soon as the function terminates. Okay, so if I try to refer to cat in the global environment, it says, hey, this thing's not defined. Okay. Any of these parameters, right, like Bruce that we've defined in here, this also is not defined inside kind of our global environment, right? So the parameters are local. Anything outside, there's no such, these objects don't exist. All right. If you do encounter some kind of error, right, Python often prints out the offending line. And it kind of does this until it reaches what we call the topmost frame, right? Values that are not defined inside a function are defined in kind of our main, double under main, okay? And this is kind of the top level script environment. So here we define print twice, and I'm doing it again, and I have cat twice defined here. And so here we're gonna execute execute this, all right? And so the problem, what is the problem here? I've defined this function print twice using Bruce, yet within this function, I refer to this variable cat, okay? So cat exists defined in here, but when I call this function, it's expecting the arguments Bruce, and it has no reference to what cat is up here, okay? So when you do the error traceback, it says, okay, first this is the line that you ran, cat twice. This is the thing that caused the error. So let's trace. When you look at the code inside cat twice, it tries to execute this, and this part ran fine, and that part ran fine, but we encountered an error here. Okay, and when we look at the code inside print twice, okay, the problem, we encountered an error right here, right? And the problem here is that cat is not defined inside this thing, right? So the traceback here, I think, is very nice. It's handy in that it tells you exactly what it's looking at and where it's encountering the errors at exactly which function call. All right, so I've kind of broken that down as far as what happens, and finally, so this final traceback shows us the contents of print twice, and it says the offending line is line 2 when we try to print the variable cat, and it says cat is not defined. Okay, and that's because it's cat is defined only within the scope of this function and not inside that function. So we can run the same code, all right? But here I'm going to define in the kind of this top level global environment, I'm going to define a variable called cat, all right? And this cat is something else entirely. So here I've got print twice. We're going to call, it's expecting the argument Bruce. I print cat, and it's going to print cat. I define cat twice as pasting parts 1 and part 2, and we want to print it twice, right? So here it's going to, when I run this, what is it going to print out? Yeah, Daniel.
Bitty bitty bomb bomb, bitty bomb bomb.
It actually won't print bitty bitty bomb bomb.
Oh, right, because cat is defined.
Because cat is defined as this thing, something else entirely. So it's going to print the something else entirely twice, right? So if I had defined it correctly, as we did back here, where the naming of the arguments and what it's being used in the parameters, we would have gotten this. But because in the definition of this function of print twice, we called Bruce, but it's printing cat. When it looks for cat, it doesn't know it's not going to look in the function that called it, right? So this function, cat twice, calls the function print twice, right? But it doesn't look there. It looks at the global environment, right? So inside this function that says print twice, it says I need a value for cat, and it doesn't find anything in here, so it looks up in the global environment, and it finds something else entirely listed in the global environment, and so it's going to print that out twice, right? So all of this stuff with bitty bitty bomb bomb just disappears, and it's lost. Okay, so how do you find stuff? So one thing about Jupyter, that's different from RStudio is you don't have kind of this nice little panel of like your currently defined environments and stuff, but you can always kind of look up what you have, and so you have %who, right? And so these are all kind of the objects that we have listed in the global environment, and then who s gives you more details. All right, and so this is kind of just like, as of now, these are all of the things that we've defined here, right? And so we see all of these different variables that we've created and their current values. And then if you want to kind of refer to each of these things individually, you can also. So this just prints it out onto the screen, but if you want to like reference them, you can also get the names printed as a list, so you can subset this. You can subset this to like the 4th object or something like that. Whereas this is just just prints information onto the screen. Okay, and this is just a feature of IPython, which we're using. It's not part of your base Python thing here. All right. How many view quizzes have they given you? Just one? 2? Okay. Your third view quiz answer is the letter E. E as an elephant. their Greek was answer is the letter E. E as an elephant. Okay, and I hope we can get through some of these scoping rules. So again, when you do assignment operations, within a function, it's only going to affect values inside the function. So here in the global environment, I'm going to have x is equal to 5. And so if I ask, what is x? X is 5. Here I'm going to create a function called alter x, and we're going to take x and add 1 to it, right? And we're going to return that value, right? So when I call alter x, it returns the value 6. Has x in the global environment changed? No. X in the global environment is still the value 5. Okay? So even though I'm adding 1 to x, this just happens inside the function. It doesn't actually affect anything outside. Okay? If you do want something, okay, you can use this keyword global. Be very careful because it's going to change stuff in the global environment, which if you're not careful can have unintended consequences because you might be affecting other values without necessarily realizing it. Okay? So here I'm going to create a function called alter global x, and here I do global x. Okay? So notice for alter x, I call x in as an argument. And here for alter global x, I don't actually need to call in any kind of argument here because we're just going to refer to the x value in the global environment. So we're going to say, okay, find x in the global environment, then do x plus 1, and return that value. And so this is going to say, all right, let's look for x in the global environment. So here, x in the global environment is going to be defined as 5. I do alter global x, it returns the value 6. And what is x in the global environment? It's now the value 6. Okay, so global is kind of saying, you know, find this thing there. Okay. If a function calls for a value that's not provided in the arguments or not defined in the function, then Python searches for the value in the higher scopes. So here, I write a function called search for x, and it doesn't take in any arguments, and it's just going to kind of, if we say print x, so it's going to look for, because x isn't defined anywhere inside here, it's going to just look for it, and it's going to print and return it. So search for x, it prints out it finds 6 in the global environment, it prints it, and it returns it. There you go. Okay. So how does scope order works? So first, it's going to search the local scope. Okay, is the code block or body of any kind of Python function. This has all of the names that you've defined inside the function, and these names are only visible from the code of the function itself. And then it might search an enclosing scope. Okay, so that is for functions nested inside other functions, not functions that are called from other functions. So over here, you know, when we did print twice and cat twice and all of that stuff, we're calling the function print twice from this function, but print twice is not defined inside of this function. So this doesn't refer to that. When we're talking about enclosing scopes, this is for functions defined inside other functions. Okay, and if you do that, then it will search the enclosing scope. Okay. And then, and if it doesn't find anything in kind of the enclosing scope, then it'll search for the global scope, okay? And that will be anything in the global environment. And then if it doesn't find it in there, then it's going to search what we call the built-in scope, okay? So the built-in scope has kind of all of your keyword functions and exceptions. So things like print and stuff that you don't have to define the function print if you want to use it, that exists. Okay, so here's just a few definitions. Okay, so here I'm going to define x, y, and z in the global environment. We're going to define function f. Within function f, we're going to assign the value 2 to y, and then we're going to return x, y, and z. And so what's this going to do? It's going to find in the global environment, all of these things have the value 1, and here it's going to search for the value 1, and it finds the value x. It's going to search for x in the global. It finds 2 locally defined. It's going to search for z in the global. And so when we do that, it returns 1, 2, 1. the values in the global environment are unaffected, X, Y, and Z. Okay, all right, so I've run out of time, but you can kind of go through some of these examples as far as, enclosing scopes and whatnot. So just on your own time, just read through these scope examples, and we will see you on Wednesday then, okay?